Well, hi, and welcome to my shop, and thanks so much for joining me here. Today is February 18th. My last video, very long, 2.5 hour video, was about comparing these two radios, and at the end of it, frankly, after 2.5 hours, I'd kind of seen enough of them. But since then, because it's been a couple of days since I did the work, I've thought more about it, and I think there's a bunch more stuff I can do with these two radios that I'm interested in doing. So I'm not sure I'm starting another 2.5 hour journey here, but I am going to set these up for more comparative testing, and I'm going to try to resolve or focus on the slight difference in operation between the two radios. I think this one being a little weaker, and I'm going to kind of verify that kind of stuff. A couple of old capacitors still in this one, maybe that's the cause of the difference between them. And then once that's done, and I really think I've finished off with these two radios, I have two more. Yeah, so let me get these guys set up on the bench here for some mutual testing. That's right, I got two more of these radios, but not a baby champs. The other two radios are champs. I just thought I'd give you a close-up of the baby champ there. Is he wearing cuffed up pants? What kind of a baby is that? Okay, my plan of action here is to test the same points on each radio, test here, and observe the difference or the sameness on my meter. And just go through testing voltages, blah, blah, blah. I don't even have to know exactly what I'm testing as long as it's the same thing on each side. And look for anything that might be out of sorts, and then I can investigate that a little bit further. Of course, the risk here is that both radios have a similar defect in them and give the same incorrect voltage. But I don't think that's really a big concern. You have a nice piece of paper here, just out of view, ready to record any particular observation that I make. Now, here's the thing. Listen to me carefully, but never imitate what I'm doing here. So these two radios have hot chassis in them. In a sense, hot chassis is a safety concern, and potential here for a firm short circuit is pretty high, especially with what I'm about to do. So, in the past, I've carefully plugged these radios in to this so high safety plug expander. That's like 40 years old, this thing here. I don't think you can buy anything like this anymore. So the relationship between the prongs and the two radios are fixed by the fact that they've been plugged in here. So I've been careful in the past. I can plug this into my power supply here. There's no contact between these two radios. There's no power to them right now either. First thing I want to do is I want to find out if there is going to be a voltage between the chassis. If somehow I reversed one of those plugs over there, there could be 120 volts sitting there, and it's a very dangerous 120 volts. And the other problem here is I can't spot my voltmeter because I organized my shop a little bit. Here it is. It's always the case, isn't it? You ever see those studies of people who maintain perfectly clean and organized, say, office desks or office work environments versus people who have papers scattered everywhere? When they have a competition, I watched this on TV, they had a competition between two guys who were highly organized and highly, what you might think is disorganized, and they discovered that both of them had their university degrees in their office somewhere, and they asked them to find them. Well, the guy with the messy office was able to satisfy all those questions just as faster than the organized guy, shuffling through big piles of junk and that. Okay, but I try to maintain a fairly organized shop here. I try to keep my bench fairly clear. You see, it's not really cluttered up with stuff, because I find when it gets cluttered, everything gets cluttered. The work gets cluttered. Your head gets cluttered. Time gets wasted. Here we go. Is there an AC voltage between these two chassis right now? And the answer appears to be no. Appears to be. I haven't got the power turned on. Make sure these are both turned off. I don't want them on just yet. They're off. Okay, check now. Even lower. Kind of interesting. Now, to absolutely prove this, I'm going to reverse this reverse one of them. And come on out of there. Let me just make sure there's no contact between them. No, nothing. And now test them again. There it is. Kill you dead. Just have to push my hands a few inches forward and I'm done. Let me put this back. It's really important I get this right, obviously, but for another reason. Because I'm going to have to use a common ground between these two radios to run this meter if I'm going to use the probe like this, without moving the ground. My plan is not to put a tie between the chassis, but to put the tie between the B- points in this radio. Okay, so let me just pick off a B- point here. That's a safe place for everything. This is probably a good one right here. So the radios are not on. This is the same point right here. Nice 0. Now, if I reverse that plug, this will be 120 volts again. 0. But now I'm going to turn them on and double check this. So they're going to go on now. As soon as I get strong enough to turn them on. I'm trying not to touch both not with that. Touch both chassis. Got them close together, you know, it's kind of counter. Now, will that have made any difference? It shouldn't. It shouldn't. Still get a 0 between the chassis and B- to B-. We still get a 0. What this allows me to do now is boldly take a clip lead, very boldly. I've got one that's long enough here. And I'm going to double check this for continuity. I have this really neat little wire tester here. It's good for continuity testing. Yep, no problem. Good for quick continuity. I'm going to tie the negative bus eye. Negative bus eye. Would that be right? Oh! Oh my gosh. That's this radio. Is that interference? Or, like, is that a signal being received? Or is this thing... I don't know what to think. This guy hears this. Where's he tuned? Let me tune this one into a similar spot. What's he hear? That doesn't sound right. Oh my gosh. Well, I'm just not sure what to do next, that's all. What I'm debating with it, well, should I just continue with what I was going to do, or do I need to investigate this right away? I think it needs to be investigated right away. Oh my gosh. Don't throw me off already. Okay. Tune the radio somewhere. Old Faithful here. AM band. Wow. I have the feeling It's motorboating. But wait a minute, this is the guy with the old capacitors. How come this one's the one that's motorboating? Good question. Okay, so what I'm going to do, since I think it is this radio that's making that sound all on its own, all indications are, I'm going to carry on. Maybe we'll find something while I'm doing all these comparative things. Okay, now, with both radios switched on, hooking up between the B minuses. You know what? That's not a good idea. Both radios switched off. It's not a good idea because these clip leads can misbehave. And that's good. That's good. Just tuck this under here. I won't snag it. Okay, power back on. So the meter we're going to be using is going to be my another old faithful here. This one here. Another issue with using this kind of meter is it has a ground you got to think a little bit about. So having applied this, I just have to clip this onto another being a minus point because these ones are busy now. A nice, safe to get on B minus point where short circuits are unlikely. Power off again. Shame on this poor radio's being switched on and off. It can be in either radio. It can be close to the chassis. So there's a black wire comes to this point. There's one that comes to the bottom of the volume control, but it's way up under there. I can't get at it. Same on this one. Show me one more negative wire. So they've used a black wire in this radio. They used a yellow wire in this radio. There's a black wire here. It's a yellow wire over here. And it's black wires there, and it's yellow wires over here. Here they use black wires here, but it's orange over here. Oh, this is an interesting comparison right here. And red wires, because I can just look back and forth very quickly. Ah, that was worth spotting. The red wires look the same. Green wires the same. I don't think there's going to be any wiring differences. It's just curious that they changed the colors of wires. So these are like, plastic insulated, and then these are cloth insulated. This is coming from the light bulb socket. And same thing over here. Just interesting to use a different kind of wire. They could have been buying these light bulb sockets pre-made by somebody. Doubt it. Just made in their shop somewhere. Find a spot, Jim. Clip on. Okay, I'm going to join down here. It's the best I can do. It's just not going to be suitable. Because I can't keep my eye on it, right? While you're working away, things happen, a fraction from the edge of your view. No, I can't do that. Let's try this. Take that off. This one on firmly, if there is such a thing, and we'll put this one on. Okay, bit of tape here. Sticky side out. Okay, I'm happy now. I'll turn on our meter here. So the first thing to take a look at, I'm sure, is the B plus voltage on the capacitors. Ooh. Well, we can assume that interference sound came out of this radio too. I'm not sure. I only had one turned up at the time that happened. Okay, B plus. 150 volt scale on the radio. B plus on this capacitor shows up as so 150 volt scale. About 94 volts. And on this guy, oh my, look at that. There you go. Well, didn't take long to find a big difference here. B plus on this radio way off at 62. I started writing numbers down already. So, look at that. B plus on that capacitor on this side. Stay focused right on this. 94. And B plus on the other side, way off. Am I definitely doing the same connection? I may not be. I'm not doing the same connection. I'm not doing the same connection. I made a boo-boo. Okay, this guy again. Do the same connection. 94, and it's a little hard to believe what that last reading was. That's more like it. 94. Okay, 94. Yeah, that's great. Do these tests, make mistakes, think you found something when you didn't. Red herrings all day long. Okay. B plus the same. Now the other side, or the other B plus, which is going to be this one. 64 and 62. Is it the same? Okay, we'll start at the bottom. If we hit the heater here, you might just get a funny looking reading. $94 on the blue. 94 on the blue. Nothing. I think there should be at least. What am I on? Am I on the rectifier tube here? Yeah, I'm on the rectifier tube. Okay, over to the output tube. Do them in order. Pin 1 open, pin 2. You know what? This is showing something here. Pin 2. So I think this is the cathode. So we have a minus 7 volts on the cathode. Minus 7 volts, exactly the same. Next pin, positive, back up to 150. At 90 almost exactly. 90 almost exactly. Next pin, 62 or so. And over here, this is just coming from the power supply that we already measured. 62, about the same. Coming around to here. Nothing. 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 A little negative on that. Okay, a little negative on that. 4 on that. 4 on that. Negative 4. And now there was a low voltage here of what is that? That's I'm on the 5 volt scale. That's 3.5 volts. That's a little different. So I changed this resistor, and I did not change this one. I think that's an interesting difference right there. What happened to the putt-putt? So the thing about that putt-putt is very often in my shop I hear that sound when I'm working on radios. Many radios produce that sound. And I'm convinced it's interference coming from my house. It dies out the same way, just slows down and stops. No idea what the source of it is. I don't even know what it could possibly be at this point. Today in my shop, I convinced myself, oh, this time it's coming out of this radio because this one's not doing it. So if it's an interference signal, surely both radios would pick it up. That was some kind of machine starting up there. But now it's stopped and gone away the same way it has in the past. The difference is I've had two radios on my bench at the same time, only one of them hearing it. How can that be? Let's just put it on the list. Put it on the ever-growing list of things that happen that I can't really get to the bottom of. Okay, let's just keep a focus here. Try your best to keep a focus. So the resistor here. So what should this pin voltage be? Anyway, which pin is it? It's pin number 8. Pin number 8 on the output tube. Let's take a look. Okay, I've got the schematic up there where we can read it. Especially if you're watching a big screen TV. Let's go around on this tube now. Pin number 2. Pin number 2 has got a negative voltage on it of, oh yeah, so that's pin number 2. Well, that's a heater. Well, I'm going to ignore that. It's the same on the other radio, is it not? It was the same. Okay. Pin number 2. Pin number 3, 126 volts. 1, 2, 3. 3. Left on negative. 1, 2, 3. That's supposed to be 126. It's 90. So the thing about the comparison back and forth between these radios is if they're both out of whack, after all, the same guy fixed them. 90 over there. So I felt pretty comfortable seeing 90 on both. 126. But the B plus in here is only 90. So how do you get 126? 90 is low for a radio like this. How are they doing these readings? Are they doing them to the chassis? I can't imagine. We have to check this. We have to look here. Oh, where are they going to have a note like that? All voltage is read from common negative lead using a 20,000 ohm per volt meter is pretty good. And again, on the 100 volt scale, that would be 2 million. Yeah. That's a good meter. So similar to the one I'm using, in fact. Could be minus, just like I'm doing. Okay, both radios are low. Both radios are low. Now let's look right on the rectifier here. Look on the rectifier tube. Possibly see it on the little screen there. So I'm looking at this on a full-size screen. 132 volts. Let's check that. 132 volts on pin 8 of the rectifier. So the rectifier is here, pin 8, pin 8. Just trying to spot it here for sure. Right here. Maybe not right here. Maybe that voltage is an AC voltage. Looks like AC. See how my meter's jumping around? Not going anywhere, but it jumps around a little bit. Up and down. Looks like an AC voltage there. 132 volts AC doesn't make any sense either. There's no 132 AC. It's got to be DC. I've got the wrong pin. I must have the wrong pin. I got something wrong here. 150 volts. Pin. Oh, maybe I did miss it. Pin 8's tricky. Oops. Camera okay. Pin 8 is tricky. It's down here. 90. So we're starting right off at 90 volts when it should be 126. 132. In this radio, excuse me, the original capacitor is still in place. In this radio, the original capacitor has been totally replaced and removed from the circuit. So they're quite different, working the same though. You know what it is? For crying out loud. At the dim bulb. Solve that problem. I have solved the problem. It's this radio. Is it? Oh boy, aren't we going backwards today? So if there's an almost short circuit in here or something crazy like that, I can create the final version of it here by accident. That's a weird sound. It's a very weird sound. It seems to come along like every 10 seconds. Oh, it's something in here. The tube. You know what it sounds like? It sounds like a heating effect. Something heats up, does something, cools off, heats up. Just this radio. I don't know. Clip lead's in trouble. Yeah, good thing I checked it. Yeah. Good. Okay, I'm gonna slip that right into the radio. Power's off on the radio. This is the ground here. B minus rather. I can put that like that. Just hold together a little bit here. Okay, let's try again. And now, what do we get for the B minus? How did you get those other? Oh, okay, never mind. 130. Better than ever. 130. 80. And 30. Okay, both the same. Funny noises all gone. Could have been that clip lead. So back down to here. That'd be 126. Good enough. And what does it say on the 126? How do you like that? 79 on the screen when I find it. It's 126. There we are. 82 is supposed to be 79. Perfect. Now we'll go back to comparing them. 126. 126. 80 dead on. 84, slightly higher. Okay, let's go to another tube now. Be 1 or 2 high voltages on this tube. Let me find them. 50 volts with a click. $60 volts. It's 58. 48. 58, 48. What's supposed to be 50 volts? What is supposed to be 50 volts? Turn both these down just a little bit here. Okay, let's look into that. So that tube has to be the detector tube. And the detector tube, 56 volts on pin number 876. The plate. 56 on the plate. That sounded right, didn't it? Just under 50. That's correct. 56. This one's a little low. There's a resistor right here. And I left it in both. Plate, detector, low. Plate, I mean, just make a note. Plate, detector, low by 10 volts. Okay. Move on. Jump up to the next tube here. Go on where the red wires are. 82 again. We're going to see the same voltages because they're just snaking along on the same wire. 80 and 82. And just looking for something else to compare. There we are. This looks like must be 82. 82. About the same. Okay, now we're going to go way up here. Here's a red wire again. It kind of has to have the same voltage on it. 82. 80. And the plate. That's interesting. We'll check that in a sec. Is there no screen in this tube? There it is. I did it. 82. Oh, how come both these are 82? 82 and 82. What about over here? 80, and 80. Well, that sounds kind of reassuring, doesn't it? Let me look at the schematic. So we're looking over at 70, looks like 78 and 79. I can see on the schematic. So we're in business there. I think what they're probably doing on the schematic is they're noting the key voltages. They're just noting the voltages you'll find on the screen and plate. And that's all that's really important. What about the grid voltages here? They've got something with 5.4 on the output to pin 8. 5.4. So that's exactly 5.4 on that meter. Sorry you can't quite read the dial. You'll have to trust me on that. Oh, that's quite different. I did something different there, didn't I? 5.4, but on this one, that's interesting. 7, almost 8 volts. Now this is the bias voltage I'm pretty sure we're reading. This is the cathode resistor here that I replaced. Over here I didn't replace it. We're getting the appropriate voltage here. 5.4. Exactly 5.4. But on this one where I didn't bother replacing that resistor, so that's cathode resistor, cathode resistor. Okay, made a note of that. What else can we find in here? Look at these capacitors, and we'll look at the voltages on either end of each of these capacitors, if there is any, and then compare it. That's it. That's it. Don't lose your grip, Jim. Okay, so we have a negative voltage here. Very small. So this is on 5 volt scale now. So this is like 1 volt sitting here. That's suspicious. 1.5 volts. That's a little. I don't like seeing that either. A little voltage there of. It's very low, 0.5 volt. And the other side. A lot of wax on those. Nothing. Nothing, and that's because that's a negative point right there, a B minus point. So this capacitor and this one are hooked up B minus on the other side, so we can only get a voltage up here. This one, oh, I got to change this. This is the one that goes to the chassis, and can't. I don't know what it would mean if we saw something there. Okay, now the last one. This one. Now I made a change in this radio. This capacitor finds its ground down on the shell of the capacitor originally. When I replaced it over here, I just attached the ground right here because it was right here. I didn't think it would make any difference, and I don't think it did. But let's find out. So on this side, it's a tiny little voltage there. Another. So that's on the 5 volt scale, 2 volts. That's not what I was expecting, but there it is. So 5 volt scale, that's 2.5 volts. I think I said it wrong over here. Well, they're pretty close. It's just slightly higher here, not much different. So, not really finding anything different about the either side of these capacitors. I mean, these ones look so good, I've left them in. It's going to go right in and get rid of them. But Okay, so what's the end result of this? Cathode resistor on the output tube, this one probably needs to be changed. And plate voltage low on the detector. I don't know, I'll have to investigate that. And plate voltage on the detector is pretty darn important. Let me double check that. Detector plate voltage. The detector plate should have 56 volts on pin number 876. On 6. 1, 2, 3. So this is 48 volts. .58 volts. It's supposed to have 56. So this guy is coming up 10 low for some reason. I'm going to look into that. Look into it right now. Oh, the schematic's right up on the screen here. Let's just take a look. Detector tube. And low on the 56. What do we got here? So we got the 56 volts is getting there through this resistor, number 15, and from there it's on a wire. We know the wires are consistent in the radio, so it's got to be this resistor. Resistor number 15. Let me write that down. It's resistor R15 over here. R15. Turn the radio off. So R15, how much should R15 really be? Let's find out here. R15. R15. Number 15. Component 15 is a resistor. 0.22 megohms, 220K. 220K. So we'll try reading it in the radio here. $220K. We'll do the reading in both radios. The resistor's in the circuit, so it may be, the test may be interfered with. Which one is it? Hold on, I get my head straight here. Might take a while. Detector tube 15 off of pin 876. There's that resistor right there. Going from here to here. That's a little, that's not exactly 220, is it? Okay, now same test over here, because this test may be bogus in some way. What do we get over here? It's a little high too, but not much. There we go. So this high resistor is dropping too much voltage, and the plate is getting starved of voltage in the detector. This was the stronger radio, as I remember right. So I will change that resistor. Now what was the next thing? Next thing was plate low on the, no, that is plate low on the detector. Cathode resistor. As I changed this one, I didn't change that one. So we'll do the test over here and see what a good reading looks like. This is very low resistance. $197. This is actually 220. Oh, that's not good, is it? $600. So this has to be at least 600K. This has to be at least 600K. Radio is off, but I'm going to unplug it here. There. Let's see if I can test it like this now. Oh, she's a bad one. Bad one. I was going to leave that in there. Shame. Okay, so that resistor goes, and so does R15. I'll make those two changes, and then we'll carry on. Great. Okay, I've got the replacements done. The resistors I took out are definitely bad, definitely gone high. Shame on me for having missed that first time around, but I got it now. That's good. So I think electronically these two radios are really very identical now. So the question is, do they perform identically? The last time I tested the two of them, it looked like this one was a little weaker. Weaker at the IF output, or weaker at the detector, or more specifically, lower AVC voltage for the same input on the antenna. But was it the same input? I was using an antenna head mounted, just hanging in my shop here, kind of broadcasting to these two radios, which were positioned an equal distance away from that source antenna, but how sure can I be that that was the same thing? So I'm going to feed a signal more directly into the antenna from my signal generator, so I know the radios are getting the same input, and then we'll measure the output and see what's up. And if this guy continues to measure low, then I'll blame one of these guys for it. Trying to figure out which one to blame, because I've still left these three capacitors in over here. And we'll go from there. So next stage, get these radios set up for comparison. Okay, here's what I've got happening here. So I've got the signal generator over there running. It's putting out a kind of a medium signal at the moment at 1400 kilohertz. And then over here I've got these two vacuum tube voltmeters going. One is going to be connected to one radio and the other will be connected to the other radio. I've made those connections. We have to make sure the calibration of these meters is similar. It should be pretty good though. We'll find out before we get too far into it. Each one of these would be measuring the AVC voltage at the same point in each of these radios. And the signal from the signal generator is coming on this black wire, and you can't quite see it, but it's connected to the antenna terminal back here, and then there's a green clip lead that runs from there to the antenna terminal on this radio. Here it is here. Is that really the best way to set this up? Well, I don't know. I think it's okay myself, but you might argue you've got to split the signal and balance it out to both radios. I'll make this as scientific as I can, but really, this is really a shop full of old equipment, so come on. With an old guy in it too. Now, next step would be turn on the radios, get them warmed up, get them tuned to the same frequency. Find that signal generator on. So check it, make sure they're plugged in. Okay, just hesitating there, you know. Key moments, plugging stuff in, turning stuff on. It's the moment before you commit yourself to disaster. This guy's on. This guy's on. There we go, dim bulbs just because I'm a chicken. Okay, there's no problem here. Everything looks okay. I actually have these two meters hooked up, but they're not set yet. So I'm going to disconnect them, in fact. So they're not reading the AVC. I've got them clamped to my desk here. So one of the first things we got to do is measure the same voltage with each of these. No. What the heck is that? What was that? That seemed to come out of both radios, but I really can't be sure. So let's start with measuring the same voltage with these probes and see what happens. DC plus 150 DC plus 150. Set the same. The zero's off here. The zero's way off. Okay. It's a funny look in the bit of an optical illusion, but this looks like it's not on zero, but it is actually on zero. So I'm just going to pick one of these. I'll pick this one over here. It's easy to get at. There we go. And just 1 meter at a time first. 130. And the other meter says 130 and a little bit. Just a little bit higher. So I can't. Okay, let me do that again, just very, very carefully, and then I'll make an adjustment. So that reads basically 135 on that meter, and this one reads 130 right on. So we're going to be reading the AVC voltage, very, very small voltage. Maybe the difference is actually not that great. Yeah, I think, okay, so this one's reading a little higher on this scale, but we're going to be on a different scale and everything, so they're close enough, close enough. Well, let's carry on with my plan. If it doesn't work out in the end, we'll do something. So this is now, I'm clipping this on for the AVC voltage here. Let me just clamp this down on my bench so I don't have a... What I don't want to have happen is I walk by and yank on all this stuff. I have 2 radios tumbling around on my bench. That doesn't sound like a good idea. Okay, now we're all set here. We are. So a little up on the volume. Tune to 1400. Hear it. There it is. DC minus. DC minus. 15 volts. 15 volts. Okay, tune for maximum. Okay, that's tune maximum. Now we'll do the other radio. How's that funny sound? Sound like my stomach. Let's hear the 2 of them. Now this one here is a heterodyne, which, let me just vary the frequency here a little bit. I don't know what to make of that. Okay, we're right on 1400 now. Oh, that's interesting. I don't think this one's going to sound like that. No, see, there's no heterodyne on this radio. Those capacitors. Okay, now I'm going to tune them again carefully to make sure this is maxed. And then the other one also, watching that meter now. Okay, so the maximum AVC voltage I can get right now with the signal strength that's being sent to the radios is 6.2 volts here and 5 volts there. So it's 6.2 volts AVC power here, 5 there. That's kind of similar to the finding I got at the end of the last video where I was looking at my oscilloscope and noting the wave shape was a little bit smaller for this radio. It's kind of the same deal. Now I'm going to vary the input signal to the radio. That's going to cause both those meters to go up and down. And we'll see if somehow they're nonlinear. So we're going to go up by a big factor of 10 here. Let's do that again. So you can see the AVC delay in this meter. swings up and then comes back, but this one just goes up and fixes itself. Let's try it again. You know, it could be the meters. I don't think so though. Let's really hit it with a heavy signal here. Okay, that's killing it. That's just blasting into this radio. That's a stupidly strong signal. This guy's 5.6 and that guy's 5. Now we'll go the other extreme. Down. 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 So now we're reading 4, and this one's fallen to 2. Now the significance of this is the effect it has on the amplification factor for some of the tubes, the first couple tubes in the radio. The higher the ABC voltage, the lower the amplification. So this guy, well, it doesn't quite make sense, does it, when you put it that way? Let's reason this through differently. For some reason, this one is producing a higher, double the ABC voltage right now. Let me kill the signal entirely and see what happens here. That's just a little mysterious. Now there's still a signal reaching the radios, and that's just noise. Let's listen to it. Kind of interesting. The noise is generating almost identical voltages here. So I'm going to tune one of the radios a little bit and we'll see just how sensitive the voltage is to the location of the tuning. Oh, super duper sensitive. Now both radios were tuned to the same spot. Look, there's a noise signal right there. Now what I'm going to do, I'm going to tune this radio down to a low spot. I'm going to try to find the same low spot on here. Okay. I think they're tuned to the same frequency, but to be sure, let's bring up the signal generator a little bit here and tune the signal generator till it finds the radios. Oh, it's not plugged in. That's not the problem. The problem is this. Okay, signal generator signals being fed to the radios again, and tuning to find the maximum. They both. And I'm watching both of them at the same time, which is a little difficult. I'm looking in the middle. I'm looking here with my eyes, and I'm able to kind of watch both of them move as I sweep through the frequency here. Let's just go through, straight through, nice and steady. So they're probably not exactly tuned the same. So I'm going to put the signal generator right about there. Now we'll finally adjust the tuning. Okay, that one's at the top. Just by playing around with these, I'd say the ABC action is better in here. I don't know if better is quite the right word. A little over 6, a little over 5. So it's still a volt off. So, you know, what that could be from is the output of the IF is low in this radio. And so once you put it through the detector and rectify it, you get a lower DC voltage, which is what we're seeing. There could be many other factors going on in this. I think the most interesting question is it lower because of those guys? And there's really only one way to find out for sure. Let's get them out of there. So I'm going to do that. So I'm going to do it one at a time. We'll take a look at what each capacitor does. I already know what this one does. This guy connects the B- point to the chassis. Right through that great big one. You can see what I did in this radio. I took 2.1s to get there. I have to do the same in this one. Okay, that's what I'm going to work on. Then we'll test this. I'm going to write down, before I forget, because I will, the voltages we're getting right now, and try to leave all my equipment set just as it is. I won't tune the radios or anything at first anyway. So we're looking at 6.2 here, minus 6.2 volts, and in the other one, oh, I have to do one more thing. I got to read the other voltage with the other meter to double check. Right, don't write this down till you know that. The meters don't read exactly the same. So what I'm going to do is I'm going to let you see what I'm going to do. So I'm just simply going to take this off. I'm just going to put it there and see if these meters read exactly the same thing. Virtually, this one reads just a touch higher. This is 5.2 and that's 5 over there. It may actually be about 0.3. So I can do something here because I have a free hand. Let's just check the 0. So the 0 is a touch high on this. I'm going to lower it a bit. Okay, let's compare them now. And okay, let's look at the 0 on the other meter. The 0 is low over here. Uh-oh. This is gonna. Okay, both 0 properly. now the other one reads higher. Oh man, how can you be sure of anything around here? By using the same meter on both radios. That's the only way. It's the only way. Okay. On this radio, 5.2, and on the other radio, 6. So clearly this guy is still winning the race despite my bits of confusion here with test equipment. I'm going to have to do that. We're going to have to use just one meter. Even if it's inaccurate, it's relative. Okay, so let me get back to changing that capacitor there. Okay, let's check the capacitor I just took out. It's a great big guy. Looks to be in good shape. Now this guy's job is to connect the chassis to the B minus, and thereby quell any antenna action of the chassis. That's the way I would put it, I guess. You bond things together to make sure there's no voltage between them. Here we go. If you bonded the chassis directly with a wire to the B minus, the radio would become very dangerous. So you bond it with this big capacitor. Still get a shock through this thing, but you wouldn't get killed. That's the theory. Here we go. 50 volts. What do you do? Big capacitor. That's pretty good. That's really very good. 150? Doesn't open. So I think I remember testing the last one. The last one was similar in that the 50 volts, here's the one from the other radio. Same capacitor, same position. So I remember it was pretty similar. It's good on 50. And then I think it opened a bit on 150. Yeah, that's actually a better capacitor. So I can't be quantitative when I use this machine here. I can't tell you, so that's a 50,000 ohm resistor there. I can't say that, so unfortunately. Okay, that's the story. So the thing about those capacitors I have heard, and I'm not, take everything I say with a big grain of salt. If you've been watching my videos long enough, you know, sometimes I'm just dead wrong in what I'm saying, and then sometimes I misspeak. So just just like anybody doing this stuff. So that big capacitor tying the chassis back, I have heard also gives the radio access to the hydro system as a ground. Now, I don't know how true that is. I really don't. And we're down to 1 meter here, right? So we'll put this like this. What are the chances that this made any significant difference? I don't think it's much. I haven't retuned the radios. I've done nothing but put that capacitor in there. These still remain. Let's see what happened. Okay, and we'll start with the better radio. Supposedly better radio. Oh, what is that? That is really getting really disconcerting. Again, it's a heat thing, right? Something's warming up and doing that. Which radio is it? It's got to be this one. Oh, both turned down. Make it one more time. Come on. Yeah, it's coming out of both radios. Well, it could be, there's arcing or something breaking down on one radio and the interference is, and they're hooked together, right? Okay, let's check it. So on the meter, before it blows up, hurry, before it explodes. 5.6 when read without parallax. 5.1, 5.2, 5.2, 5.6. Now let's tune. So I fooled with this radio. Let me tune it a little bit and see if this goes up or down. It's pretty much right on. Try the other radio now, just to be sure. Can we get a little more out of it? Down? No, it's right on. So not much difference now between them. 5.6. 5.2. So did that help a bit? I'm going to look at what these two capacitors are doing here. One of them is okay. One of them is come on. Radios can be like that. Well, right, these capacitors, and what are they doing? It's grounded at this end, tied to something there, and the other one is, this one looks like it's more involved with the antenna, and this one looks like it's more involved with the, well, it is with the tube here. Let's take a look on the schematic, see if we can sort something out. Now there's a diagram in here. I don't have to slave over this. There's a diagram right here. It shows me these capacitors. So this one is number 21, and then this one is 22A, 22B. 22B, it looks like they're pointing at this resistor. Something funny about how they numbered these. So again, just to be sure, 21 and 22A, 21 and 22A, 21 and 22A, 21.05, well, it doesn't say what it's doing, 21, 22A, both 0.05s. 21 and 22A. So 22A is a bypass on 22B. You know what it sounds like? It sounds like they built this radio and they didn't have this is the cathode. Yeah, this is cathode bias. They didn't have this in the original, and later they decided to bring in a cathode resistor and bypass it. And that's how come they're 22A and 22B. So look, that may or may not be in this radio. Well, it must be in the radio because I got this capacitor. And then the other one was 21. So what are these guys doing? So this is really important. This guy is grounding out the bottom of this secondary side of this transformer. So you're trying to pull this right down to this potential AC wise. Doing the same over this way and that way. Wow, this is a busy capacitor, I think, 21. Let's go after this one next. We kind of know what this is doing. This is a bypass and cathode resistance thing. This is interesting. This is like a pretty important one. 21. Let's look at the diagram again, just so I'm not being stupid here. 21. 21. 21 is the one that's coming that I said was probably involved with the antenna. And it isn't. 21. Let's do 21. 21 is the guy. Okay, took that out, put that in. Let's go see how this one stacks up over here. Now I'd left these in all this way because they look so great. Let's see if looks are deceiving. I already know looks can be deceiving. Didn't your parents tell you that? Somebody told me that. Okay, 50 volts. Okay, you can't see it in the camera, but it opened ever so slightly. She's a leaker. She's leaky. Looks beautiful. Very deceiving. So let's try with the radio now. And remember the heterodyne tone that was noticeable in this radio. I'm going to put down some money. I don't have any money with me. I'm going to pretend to put down some money. Here, I'm betting this light bulb that it works. That the heterodyne tone is gone. That's what I want to say. Power on. Again, I haven't retuned anything since the last blast. Let's hook up the meter to this radio and watch it go. Okay, it's stopping at 4 for some reason. Not quite sure why. I thought this was 5. It's going down a bit. Okay, that's in the radio I did nothing to. Okay, other radio. Three. Oh, I've got it on. I got the dim bulb still on. Okay, so in this radio, one I just worked on, we're coming up to 4.6 volts. Now, maybe this caused some tuning thing in that radio too. Okay, glass capacitor. Here we're getting the 5.6 here. For about 1 less. Yeah, but almost 1 volt less. We tune the radios now and make sure they're tuned properly to this one. This one may make a difference. Down, down. Nope. Still tuned dead on. Just check the other radio. It should be tuned dead on also. Down and down. Let's listen to them now. So this one's got a whistle. That's what that sounds like. What's this sound like? Oh, they really sound identical, don't they? So I hear the tone from the signal generator. I hear another pitch, a higher pitch in there. And that was this radio, and this one, same pitch. So that's some kind of interference signal, something like that going on. Where'd that sweeping heterodyne go? There isn't any. Okay, listen to the sound again as I tune through it. Let me try it again. Yeah, my imagination. Okay, never mind. Imagining things. Well, they're really close in voltage. Now, another factor in here that can easily be responsible for the variation in the strength of the output of the IF is the vacuum tubes in the radio. So we're going to have to get around to that too if I really want to try to nail this down. We have one more capacitor to go. That capacitor is, what is he doing? So he's on the IF, well, it's on this terminal of the IF tube, IF amplifier tube. And that terminal is 1, 2, 3, 4, 5. Terminal 5 of the IF tube. Let's check out the schematic here. Terminal 5 of the IF tube. Terminal 5 of this tube. One, 2, 3, 4, 5. Oh, right. It's this bypass. And then we gotta look at 22B. We gotta check that resistor. And then checking the volt radius. 22B. Because the cathode resistors sometimes work hard. Maybe not in a signal tube so much. 22B. And 22B. 22B. 270 ohms. Why is this ringing a bell with me? 270 ohms. Okay, let's look at the combination of the bypass and the resistor here. Okay, where are you in there? So that's probably the resistor, just up above the capacitor there. Watch your finger check. And that is its value. It's a moderate wattage one. It's sitting over here in this radio too, right there. Looks like, to me, it looks like red, brown, brown over here, and here it looks like red, brown, brown. That's 210. What did it say in the manual? I'll just take a peek myself here. What did it say? It was 270. 270. So maybe that's a purple there? Well, I don't know. Let's take a close look. Now the radio's on. Don't forget. Yeah, I think it is purple. So that's 270. Look where it is. Oh. And then there's the capacitor right there. Okay. And then the other resistor, the other radio. Now we start by measuring these resistances. Sticking your finger in the radio. Everything is solid. We'll read those resistances. Let's read the resistances. Now they're in a circuit. Again, the reading might not be correct unless I really think it through. But then again, these two radios are identical. So whatever. So comparatively, we can look at these at least as an initial observation. What is happening? Okay, just stand there, would you please? It's supposed to be 270. Let's go down there. From here to here. 350. So the reading is, now how can this be? The resistor is supposed to be 270. So if it's 270, we would read here, 270 or less. 370. It's a cathode resistor. Its value is quite critical. Even at 10%, you might want to think about changing it. So it's way out. They're both way out the same amount. See, they're in there really nice, and I don't want to go in there and fool with this that I don't have to. We'll look at it on the we'll have to look at it on the schematic and see if we can reason out how could you possibly get this kind of reading. It's just not possible without the resistor going high. I think we're actually reading the resistor. Interestingly enough, both of them, 379 and 350. Isn't that interesting? Really makes me think there's a parallel path in there. Let's take a look at the schematic quickly. See what we can see. So we're talking about this capacitor and resistor. If we go up this way, it's a dead end. Wait a minute. There's also a suppressor. So the suppressor is connected not to the cathode, but rather to the B minus. You know, often the suppressor is just connected right to the cathode. That's kind of interesting. They added this in, so I assume the 22A and the 22B were added in afterwards to change the bias on this tube. I wonder if this wire should have gone up here at that point. I wonder. Look at another tube. Oh, let's not look at that. Let's not look at that one. Let's not look at this one either. So we won't have really another good example to look at. This is the only one with it, you know, three grid tube in here. Well, you know, I don't know. So I'll just leave it the way it is for now. But so that last capacitor then is this guy. So if he's not working well, 22B is quite a low resistance, 270, and you know, usually you're bypassing a low resistance like this with a large capacitor, like it would be done over here with a large, I think that one, a large capacitor. Well, I think we got to get rid of this guy. If he's leaky, I don't think it's that big a deal in terms of the radio operation offhand, unless it's terrible. Let's get him out of there and we'll just see what happens here. Sooner or later, they all gotta go. We all gotta go. So this capacitor is finding a ground down in here. When I replaced it, I moved it and grounded it here, which I think I'll do the same thing on this one. Try and nip down on that wire down there. Oh, boy. So I'd have to admit that I don't pay that much attention to, or as much attention as maybe I should, to resistors and radios. It's been my experience that they're just most often okay, except for these cathode resistors in particular. Let's give them a test right away. Camera's rolling. My tester's hot. Tested while it's hot. Okay. 50 volts. Open a bit. No. So even though these look spectacularly good, they're really just as bad as any other capacitor. You have to think, does wax hermetically seal anything? So the only thing that blocks moisture is metal. So if you even glass has a vapor transmission rate extremely low, I'm sure. Maybe that's not the best example, but many other materials, all other materials have a transmission rate, I guess probably at a molecular level for moisture. So beeswax, no. Tin foil. Why do, when you buy your potato chips, does it come in a plastic bag but it's actually a metallized plastic. It has a tin or whatever aluminum layer on it. Why? Block moisture. It's the only thing that'll do it. So when you buy your chips, if the bag appears to not be metallized, then maybe you're going to buy stale chips. And I can't remember if I won this or I lost this. So next step, having just is it change both these resistors. I'll take one out right now. I'll take one out and measure it out of the radio. And they're both as awkward as can be. Oh my gosh. Awkward, maybe not awkward to replace. This is usually where I cut 3 wires. By accident. Okay, now the truth be told. Red, purple, that looks like black. I think it's brown. Okay, I need that. And the truth is, if I can read this little guy here, I didn't leave enough wire. Yeah, 350. And there's no way that's an orange band on the start. So these are really out. And both of them went out. Okay, so I'll change those two. We'll see what happens next. Okay, let's give this a try now. I've got 2 resistors installed. And I replaced the 1 capacitor. So not much left in this radio really to fool around with in terms of replacement. I guess just the vacuum tubes really at this point. We will see. Let's apply the test here. Just clean up my spot a little bit. Now the other thing about having a lot of stuff on your bench is that when something bad starts happening, you have to examine all that stuff on your bench to figure out, how to respond. It's too much stuff. So there's the 2 bad resistors. That's why I like to put away the tools periodically, just get them off the bench and all that. Okay, I think we're ready now. Power on. And you keep an eye on this meter. It should start going up. There it goes. Ooh. Supposed to go a lot higher than that. What's happened here? Okay, let's not panic. What's the other one doing? Even less. Did something happen to the tuning of the radio? There's no signal there. Maybe I fiddled with them. Did I fiddle? I fiddled. Maybe I fiddled. Oh, they're both gone somewhere else. Okay, let's start with this one. Did it just change all the... doing that? Did it. Okay, this guy. About the same thing. Oh, what's that? There's that heterodyne thing. I wonder if it's because of this radio. It's a local oscillator in this radio. You would think this radio would hear this one too. Nope. But for some reason, the local oscillator is not broadcasting into this radio. That's a curious thing in itself. Okay, tune them up. You have to watch this meter. Wow, it's gone way down. Oh my gosh. So the signal I'm feeding into this radio is it's kind of a moderate lower level signal. You can hear the static in the radio too. Oh, that explains it all. No, it doesn't explain it all. Tune that baby. Wow, it's way lower. .5. Wait a minute, what just happened there? Did I just tune this radio? Oh. I must be a little nuts here because the meter's hooked up to the other radio. Oh. So, why is tuning this one affecting the meter over there? It's not now. Maybe the local oscillator being picked up over here is doing something. Okay, so working on this radio on the meter. Now we got a nice voltage there of almost 5 volts. Wow, isn't that up from where it was? Maybe not. I'm trying to remember. So we can get all the way up to the top of the 5 volt scale with this radio. And what about the other one now? It's right up there. Give them a tune. Right off the charts. You know, what's happening is the difference between these radios is becoming more and more apparent. It's almost like if you have a race of people, it's a walking race, and one of them's on crutches. You have a pack of 40 people doing that. You might not spot the guy on crutches because he can get along with the pack. But when the pack picks up and starts running, suddenly you see the guy on crutches. He's been left behind. I mean, that's kind of what's happening here. There's crutches in here. So let's get the right voltage on here and actually read what it is. And listen to it too. So we're getting 6.2 volts there. T'other guy. He's still at 1 volt low. 5 volts, just under 5 volts. Could be alignment. The IF alignment disturbed by changing some capacitors. I'm tempted to twiddle just to see if there's a boost waiting. Why not? Let's do that. Let's twiddle a little bit. So what I'm going to do, I'm just going to, because I'm on my way to doing another alignment on these guys now. Let me twiddle the capacitor in the IF can if I can get at it. It's a bit of a reach for me here. This may not work out well. Oh! You see, I shorted this one. This is the one with the hot screws. Yeah. Okay. Okay. Let's not stop. Just because you're scared. Okay, we'll try a more insulated one here. You can still short it though. Get in there. Yeah, you know what? I really can't do this properly. Not like this. Darn. Can I move that radio while it's operating with all these clip leads hanging out of it? Tangle up wires here? The answer is no. So at this point, I'm going to call it a day here. I'm going to stop for now anyway. Maybe this will be the end of the video. So if it is, thanks a lot for watching. And the next video will be another attempt at doing a crazy in-depth alignment on these two radios. The thing to keep in mind is these radios are only worth $40, $50, $60 today. Maybe radio prices are going to shoot back up someday, but right now they're not worth much. So a lot of effort for very little value in the end in the radio. Okay, so I said I'm going to stop here. Maybe I'll carry on. Maybe this is going to be another 2.5-hour video. I have radios waiting. Just on second thought, there is one more thing we can do with these radios right now, and that's just listen to them. So I'm just going to leave the signal generator connected. I'll knock its output down, and it's way up. It's 1800 kilohertz, so it shouldn't. Ooh, 1800. Let's go a little higher. Okay, make sure it can't do the local oscillator thing. Turn that radio up. Well, let's do one at a time. So I'll tune this guy to 590 if I can get there. I should be hearing stations here. Not a single station. Isn't that strange? Now again, it could just be antenna. Ooh, that's really not very reassuring at all. Okay, let's try. Yeah, it's like it's not working. Type not reassuring. Let's try this guy. Okay, get something. Pretty quiet. So that's probably this one. Nope. So you're hearing this radio. The local oscillator in this one is interfering with it. Oh, that's really interesting. I'm using the local oscillator in this radio to tune this one now by accident. I think that what might be what's happening. No stations received. Neither radio. Okay, I'm going to give him some help here because this is disturbing me too much. Again, this is just an outdoor antenna. I'm going to have to run and flip it on. So let's stick it there. Okay, I got to run back in a moment. Okay, Mr. Radios. Mezzers radios. Wow. It's dead, Jim. Wait a minute. We're listening to the wrong radio. Let's try that again. That's like you have two computers. You start typing on the wrong keyboard there. Ever done that? I have. Come on. That was a bad idea listening to these radios. I shouldn't have done that. Let's try this one now. The tuning knob is sliding on the string. There's so much junk. You can watch the ABC going up and down here too. Hey, you know what? I've got the signal generator on the antenna here. Okay, we'll take it off. Let me turn this just down a bit. See what happens when I take it off? Nothing. I thought something big would happen there. Well, okay, result of this, man, all messed up. There we are. Booyah now. Bottom line is we got to go through an alignment to find out what's really going on with these radios. Very good. Yep. I think that's enough for now. That was just a little on the disappointing side. I'm not worried. I am not worried. Thanks a lot for watching, and I'm going to be busy in here later probably.